Now let's talk about the wireless networks protocol, the Wi-Fi. The Wi-Fi stands for wireless fidelity. It's a LAN protocol. It is used to connect devices in a limited geographical area wirelessly. It has the standard of 802.11 from the IEEE. We have several standards for the Wi-Fi. A, B, G, and N are the names of these standards. They differ in the frequency used and the speed achieved for the wireless communication. The Wi-Fi generally works in the ISM band, so it needs no license from the regulatory authority. It uses the frequencies of 2.4 GHz and 5 GHz, according to the standard, either it is A, B, G, or N. This frequency band is divided into a number of channels with a guard frequency or a guard band between each channel and the other. These channels are used for the communication of access points that are near to each other without allowing for interference between their frequency ranges. Wi-Fi is governed by the Wi-Fi Alliance. The 802.11 standard is the wireless LAN standard. It uses air as the transmission media, such as the rest of the wireless standards. It is concerned with the two lower layers of the OSI model, the physical and the data link layers. In the data link layer, it divides the data link layer into two sublayers. One of them is the logical link control layer, and the other is the medium access control layer. And the physical layer is also divided into two sublayers. One of them is called the physical layer convergence procedure, PLCP. The other is the physical medium dependent, PMD layer. So we have in this diagram this division to the data link and physical layer according to the Wi-Fi standard. We can establish two types of wireless networks based on the Wi-Fi standard, either an infrastructure network or ad hoc network. The infrastructure network uses the access point to communicate two devices to each other. It is a star topology. It is more commonly used to establish a wireless network inside an office, a meeting room, or a corridor, or something like this. The access point is used to connect the wireless devices to the wired infrastructure. Sometimes you need to establish an ad hoc network wirelessly. You need to establish direct communication between two laptops or two mobile phones that happen to exist in the same place. This ad hoc network is established for short period inside, for example, a meeting inside a meeting room between two persons that need to communicate their business cards or to exchange some information between their laptops. They can do this using the ad hoc network. It's suitable for meetings and conferences. It is more flexible in setup. It can be set up for some short period of time and then dissolves if these two laptops or mobile phones are away from each other. It uses the point-to-point communication topology. Meanwhile, the infrastructure wireless network uses the star topology, since there is a connecting device which is the access point. The SSID, which is the service set identifier. This is the name of the network. This is the name that you can see when you scan the surrounding area for wireless networks. It is used to identify the wireless LAN. It is the name of the wireless LAN that you choose to connect to. It can be broadcasted name or hidden name according to the configuration of the access point and the wireless LAN. The configuration says that this wireless LAN is broadcasted. Anyone that scans the network using the mobile device or the laptop can see the name of this network, or it can be hidden, so scanning the network does not show this name. If you will connect to a hidden network, you need to know two pieces of information: the name of the network and the password. Meanwhile, if you will connect to a broadcasted SSID, you need only to know the password, and you will find the name broadcasted and you just click on it to be connected. The length of the SSID can reach to 32 alphanumeric characters. This is the name of the network, can reach 32 alphanumeric characters. It can be composed of several access points. Several access points can serve the same SSID, can connect devices to the same SSID. Single access point as well can connect to several SSIDs. According to the configuration of this access point, it can connect devices to many SSIDs, many names of networks, through the same access point. In Wi-Fi, collisions are avoided through another technology that is different from the SISMA CD. It is called the SISMA CA, Carrier Sense Multiple Access Collision Avoidance. It uses two types of messages that are called RTS, which is request to send, and another signal that is C2S. What happens is that the sending device sends an RTS signal. It does not start sending until receiving CTS signal from the receiving device. That's the way it avoids collisions. But the possibility of collisions still exists. There can be some collisions, and as you know, collisions are something that we do not like over our networks, either wired or wireless. So collisions leads to poor performance, slower performance, and leads to resending several times for the same type of information. Recovery of collisions is done just simply by resending the information that has collided with each other. Resending means slower. Resending means poor performance. But this is the way that the SISMA CA depends on to avoid collisions or to recover from collisions that already has happened. By now we have introduced the Wi-Fi protocol briefly. Thank you.